Well, hello everyone. Welcome to yet another session on AI concepts, and today we are going to talk about quantization. Quantization, or interchangeably it can be called compression. This is the concept wherein we can compress the large language model into smaller the size so that it can fit well into the memory constrained devices, or wherein we need not to invest more on the hosting infrastructure. So basically you can think of we need not to use the GPU, but you can fit in the same model after compression into your GPU, into your CPU or the memory constrained devices. As good as you can shrink the size of the model up to 1/8 of the size what we see in case of the LLM or the base model. Now think of why we need quantization. So primarily quantization comes with the two benefits. Firstly, the same model that you have been using by hosting on GPU, you can host on your memory constrained devices or in your local CPU. Secondly, you will not be having the latency faced that you could see in the case of GPU. Now these are the pros. But what about the cons? The negative aspects basically with the quantization, though we get the latency, but we compromise on the efficiency of the model. Reason being, when we compress the model, we compromise on the number of hooks because we are shrinking the representation of the weights and the activation functions associated with the model into different sizes. It could be in 4 or in 8 format. Now, the quantization is something not a standard way to compress the model, but conceptually it is, and we have different way of implementing it based on the strategies. So the strategy could be something wherein you are just compressing the model weights, or it could be you're compressing the model weights as well as the activation function. So the activation function can be dynamically compressed or can be compressed to a specific size. So how does that give you the different aspect that we'll be seeing in the next walkthrough session, where we can see exactly which screen we are using and what is the efficiency in that. Before that, let's hop on to understand the basic pipeline when we are going for implementation. We'll be having a script that will be using a reference set and that script will be doing the quantization in a pipeline. Pipeline you think of as a looping function where we will be defining different configurations. Configurations are nothing but the quantization schemes that will be represented in the loop, and in the particular loop we'll be implementing the different quantization strategy on the same reference set, and we'll be able to evaluate the same using the perplexity or the evaluation matrix for the different quantization, and based on the use cases we can conclude on which quantizations we need to implement. So if you see on the screen, this is the pipeline. These are the reference set that we quantize, we will run the sample set, and eventually we compare, and based on the response we can evaluate like whether we need to go for dynamic quantization or we need to do a quantization for activation function, or we want to do activation function quantization of a specific weights or dynamic. There are different schemes we'll be seeing in the forthcoming example. Now if you see the slide, this is the loss bearing scoring. We see eventually once we are running all the configuration in the loop here, and eventually we'll be seeing the efficiency of the model after quantization. If you see in the slide, basically at a high level we can think of, if we are just quantizing the weights, we'll be getting good speed actually, because we are compressing the weights and we need not to load all the number of weights, and we are able to address the latency at the runtime, so inference is fast. However, the accuracy is something that we can gain more in case we are able to quantize the activation function as well. But the thing is, in case of activation function quantization, we need to look at the different combination that works for our case, because the multiple function or the function that happens at the hardware, it's something that directly depends on the structure that we send to the underlying hardware. Now if you see here in the example, if you see this is the particular application we have done for evaluation. Here is the configuration for different quantization. It's weight only, then weight only with particular size we have to specify, and then int only with the dynamic weight, wherein the activation functions and the weights will be getting compressed to int 8 format. And if you look at the slide here, we have already run this, and this is we are getting the response out. for different models. Same is the question. For int 8, we have asked the question about symptom of diabetes. This is the answer.